Last week, I introduced my new course, Geospatial Skills for Web Developers. Today, I'm going to talk about the first module about geographic thinking for developers. So, this course is interesting in a different way because I'm trying to be seeing the GIS and geography in a different way, particularly for the developers and coders' point of view. So, first, I want to build some basic understanding. What is web mapping is? So, according to the definition, web mapping refers to the process of designing, implementation, and publishing interactive maps on the web. There are different names. Sometimes people call it online mapping, interactive mapping, cloud mapping, collaborative mapping, and mashups, digital mapping. So there are different things, the different names. I have a slight variation based on the names what they want to be explaining. For example, the mashups usually tell you the combination of different kind of things, maps, APIs, and open source and proprietary. So put them together, and those kind of platforms refer to the mashups. So there are interactive mapping is also leading towards the way you can understand is like you can interact with the maps and you get some information pop-ups and you can make some queries, those kind of things. So you can interact with the map. So it can be implemented using open source, which is usually the free community-driven tools, or it come with the cost as the proprietary tools, which is you will learn like the comparison between the open source and proprietary tools. And sometimes they have a combination of both together in that case too. So in other words, when you look at the web mapping at the developer point of view, it's combined geographic data, backend processing, and front-end visualizations to create dynamic and user-friendly maps. So the component, which is the geographic data, is the main purpose of this course, or especially to understand and in relation with the backend and front end uh, processing and visualizations. So most of the talk in this course will be focused on geographic data, but definitely to link with the web mapping. So we need to be understand what are the backend processing and front end visualizations options and tools are available and why we need to do those kind of things. So before going into the details, I would like to share some timeline of some significant web mapping events. It's based on a research paper. Paper was published 2017, and the information is included up to 2016, but I have a next slide which will give you a little bit update post this paper work. So the major thing is when starting with the in 1989 the concept of www, and now how many things we are moved, and when the the first web map MapQuest was launched, and then OpenStreet was in 2004, and then the Esri introduced ArcGIS Online in 2012, and these are the different significant events in related to the web mapping. So in this table, you can see there's some latest information. So in 2016, the ArcGIS launched big data visualization. So this is done by the Uber's framework and for large-scale geospatial data rendering. They have a Google Maps platform update. They convert into the commercial shift, and then John Hopkins University COVID-19 dashboard, which is actually a real-time global pandemic tracking with interactive maps. It set a new trend in the dashboards. And then we have a new thing in ArcGIS Online Experience Builder in 2021. And then you can see the new things are coming, which is the spatial computing in the Apple is working on some areas, and emotional awareness mapping, which is being discussed, and it looks like they're going to be implemented in this year. So you can see the different significant things happen over since 1989, and now we have a different kind of technologies, different kind of platforms, tools, which being used the geographic data to display it, to process it, analyze it, or you can use it for your different kind of applications and commercial products like the Uber is using in their cab calling system, and you can use Google Maps for the navigation purposes. There are so many applications it's emerging over the time, which is interesting to understand. So all these things, depending on geographic data, dealing with the generating geographic data or manipulation of the geographic data for some kind of decision-making processes. So that's one most important thing we need to understand why we need to be understand um, the GIS and spatial data as a coder when we are building some front end and back end solutions. So solutions could be categorized into three different levels. We first one is simple web mapping, then we have intermediate web mapping, and some advanced web mapping platforms. So as you can see from the name, simple is more static and lightweight. Interactive maps could be, and that's mostly user can like data is not updated regularly. So whatever the information is there. You can use it and display it. And intermediate mapping is basically dynamic data APIs, which is you can see the platform. So the combination in terms of the open source and proprietary solutions. So I have those few examples for you in this table. If you want to look the simple map could be combination with the leaflet OpenStreetMap and personal projects and blogs. That would be the ideal case where people would like to be used. In terms of proprietary software, ArcGIS Online is one of the popular platforms which people are using for that. Intermediate solutions could go with the database. That's a PostGIS plus MapLibra. That's the open source combination. And in terms of the proprietary, if you extend ArcGIS Online, it could be go to the Experience Builder and dashboards, and then Google Earth engines could be one of the option as well. So people usually use for the dashboard institute medium level application. Advanced is basically where you have a large data, huge information processing, those kind of applications. You can see the Stack API and DACGL could be the one of the combinations where you can visualize those large and process those large information. And ArcGIS Pro Enterprise GIS could be one of the case studies in the proprietary case where they are using, and Google Earth Engine is also following in this category as well. So to just to be have a conceptually, so what map mapping is by definition, and then if you want to see the different scales of the web mapping, so different kind of applications we are there. So whatever the level of solutions you have, so those kind of things. So whatever the level of solutions you're thinking, the main thing is the dealing with the map, geographic data, and it could be in the raster format, it could be the walked format. So the most interesting thing is how to work on that. That's going to be discussed in the remaining course. So here I'm going to share example with you is a Global Forest Watch. It's a very nice platform. It's built on an open source softwares and tools, and that platform is basically for monitoring forests globally using satellite data. So This platform offers several APIs, datasets, and tools to integrate forest monitoring data into custom applications. So for example, it's provide a forest change data API that you can access tree coverage, loss gain, fires, and other alerts. They can provide you the embeddable GFW global forest watch maps that you can integrate in those interactive maps into your web applications. You can use the JavaScripts for that purposes as well. And data layers, they have a number of data layers, decovered loss, biodiversity, hotspots. That can also be the custom maps over there. So this application is a example, classical example where you can see the number of things to gather small maps to the more APIs, and then you have a advanced analysis tool as well. So they provide you the kind of different kind of things to gather in one platform. So this tool is usually, if you look what they are using it, so the combination of different kind of technologies. There's a Stack API, which is used for the geospatial asset indexing, is one of the key thing behind it. GeoTrails, which is a Scala and Java library for fast raster processing using Apache Spark. And for example, the NDPI calculation thread analysis can makes it very easy for by using this one. And they have another one is the raster frame, which is a kind of low-level processing, but it's doing the raster processing and enable SQL like queries on data sets. So DACGL, which is, as earlier mentioned, is developed by the Uber, and this framework for large-scale geospatial visualization, random millions of data points in the browser and 3D maps and heat maps, those kind of things. And Kepler GL is a powerful open source geospatial visualization tool for interactive mapping for large data sets. So there's a combination of different kind of frameworks being used behind this platform. So as a developer, you can see when you're dealing with this kind of coding or different platforms, so that's most important thing you need to be focused. But before doing these combinations, choosing those kind of things, solutions, you need to be understand what kind of data sets you are going to be deal, what is the raster data set is, and how you convert the raster into vector. Those kind of things is basically is important to understand when you're doing the coding. Okay, so in short, building blocks of web mapping. So to build any web map, you need to combine knowledge from a few key areas. So first one is geography and GIS, knowing what locations mean and how to represent real world things on a map. That's we're going to be discuss one of the component we have in this course. And then the second one is spatial data, understanding coordinates, layers, and formats like GeoJSON or shapefiles. Next, storing the data sets. We need a databases and storing and querying location data using a special extension like PostGIS. Web development, starting with HTML, CSS, JavaScript, to build the interface and functionality. And mapping libraries and APIs, tools like Leaflet, Mapbox, ArcGIS APIs, and last one is the user interaction, making the maps respond to clicks, filters, and other dynamic elements. In other words, answer the questions. So these building blocks, the first two will be the focus of this course, and we will discuss in more detail. And when we will be looking these two areas especially, so what are the things which we need to be know, and then I'm going to be explain most of them in detail with examples. We will have some case studies as well. So the what we're starting with is the geospatial data fundamentals. So as a coder, as a developer, you need to be understand what is the coordinate system and projections are, map projections, and usually difficulty handling different coordinate reference systems, causing misaligned layers or distorted maps. So the spatial data and the spatial data types and formats, it could be also creating confusion around vectors. We have a point line polygons, raster, usually imageries and surfaces data, and we need to be deal with other formats, shapefile, GeoJSON, TIFF, geodatabases, or those kind of concepts. And working with census and administrative geographic is important as well. So because these are the basic informations that can be used in a different way and in different application in different solutions. So it's important to understand how this information being generated and disseminated in a different level of data sets. Okay, so lack of familiarity with standard units like census tracts or dissemination area or enumeration areas, limiting demographic or policy analysis. Data processing and preparation. There are some important things which need to be will be considered. So one of them is the symbology and classification of the data sets. So most of the people struggles. I'm talking about more developers struggles with choosing appropriate map symbols and applying classification methods. It's very important to understand the science or statistics behind that classifications. So this is going to be we are going to discuss in this course as well. Data transformation and coordinate system conversion. So challenges in converting data sets to compatible spatial reference system using tools like GDELS or Project 4. So we need to be understand the transformation, why we need to do that, and what are the major challenges we have of the geospatial data transformation. And feature extraction from raster data, and it's also need to be understand and have a clear understanding about why we need to do, and sometimes difficulty extracting roads, water bodies, and land use types from imagery through techniques like thresholds or segmentations. And we need to be also understand the image classification for vector conversion, because like the vector data sets are being updated using the raster data like satellite images or drone or aerial photographs, those kind of things we used. So there's a techniques which is not generalized, we call the image classification. So the lack of knowledge on supervised, unsupervised, or classification techniques to convert satellite imagery into usable vector layers. That's also important to be have a better understanding why and when we need to be use these kind of things. Okay, so we are moving towards the spatial analysis and GIS methods, a little bit like moving from the data to manipulation of the data. So this is also interesting to see the spatial joins and spatial queries, why it's important, when we need to use it. So there are uncertainty about how to specially link data sets, like which points fall within which polygon. So using tools like PostGIS or TrustGIS. So this is the relationship we need to be understand of the data sets. And now there's another domain which is called spatial statistics. In experience with spatial measures like clustering, hotspots, and spatial autocorrelations could be a challenge when you want to be do some statistical analysis using a visualize as a part of the visualization or interactive mapping. Buffering and proximity analysis is also one of the things being used frequently and in a different ways. So they have a different methods. So misuse or misunderstanding of buffer distances and how to analyze accessibility or special influence. So these are the things which we will definitely discuss. I will give you some more understanding how the basic information you need to be to understand and learn as a developer to continue with your programming. So network analysis is also one of the most important things, and it's need a lot of things. Most of the network analysis which is using the road networks. So you need to be understand how the road network being built, and then you can see the use of the road network using routing, catchment area, then shortest paths and those kind of things, how you want to calculate and how the road segments and the information with the road can be used for that. Data integration and infrastructure. So we're moving towards a little bit more entering into the programming side, but as merging multi-source data sets, uh, which is usually creating a trouble aligning, cleaning, and integrating data sets with varying solutions, resolutions, formats, and attribute schemas. Handling large geospatial data sets, performance bottlenecks, or storage issues when working with high resolution imagery or large vector layers is called to be one of the things you need to be understand. These are one of the challenges. And special data licensing and privacy is also important to understand the sensitivity around the data sets. So web mapping specific challenges where we need to be learn the map layer design and rendering. So inexperience designing map layers for performance and clarity, tile layers, layer ordering, or overlapping or overplotting. This could be the things you need to be understand how different layerings could be worked together. Thematic web maps is also could be challenging, difficulty designing interactive thematic maps, chloropleth maps, heat maps that accurately represent spatial patterns. Hosting and tiling services, we need to be also discuss those kind of options we have in the web mapping. So the uncertainty around those tools, we need to be have a better understanding. So dynamic interaction and spatial APIs. So those are the few things you will be hearing it again and again, how these libraries are being used for those front ends and interface development. Last part of the challenges and basic concepts, the developer and the coder, you need to be know related to the conceptual and practical gaps. So this part is very interesting because limited GIS terminologies and concepts, generally unfamiliarity with the key GIS terms like topology, scale dependency, and geocoding. These are the interesting and important topics. Topologies, how you want to build that not network topology and polygon topology. This is important things if you want to build a high level web mapping solutions. You need to be understand these things. Geocoding is one of the important and oldest process using creating a location from the descriptive data sets, and they have a reverse geocoding opposite to that, and then you have the location but you want to generate the descriptive information address and extract the address information using this method. So those kind of things are very important when you want to build a very what is called the important solutions and real applications using the web mapping. And lack of spatial thinking is difficulty understanding spatial relationships is also a challenge, and I would like to be discuss this these terminologies and these spatial thinking in detail. So how we define the adjacency, containment, and connectivity, and because that defined a lot of things in your analysis, how you want to define the neighborhoods, how you want to calculate the distance, those kind of things you will see that depending on these conceptual or critical thinking and how they can influence analysis and design. So these are the important things which I think developers need to know, at least the way I describe them. They need to be develop their own understanding around these geospatial and geographical terminologies and their concepts, and then they can focus on certain areas which they think they are going to be used in in the area of their web mapping. I'm not saying they need to be know each and everything, but they should at least know there are a lot of things behind before starting the coding is there. So this is the thing which out of these 20 different topics, and I will in the next coming modules I'm going to be discuss most of them and try to be the show you the where people are using misuse of these geographical important those concepts and the knowledge, and if they have a better understanding how they can provide a better solution for that. So thank you very much for watching this module, and hopefully I will get some feedback so that can be helpful to develop a next module. So please let me know what you think, and if any area you think you need to be learn more, I will try my best to develop some slides for that. Thank you very much.